So this talk is efficient MySQL performance. Probably half of you know me. I'm Daniel, and I'll do a quick blurb about myself, but move rapidly. 18 years with MySQL now. A lot of people know me from my website, hackmysql.com, or you know me from Percona, where I spent 8 years, worked on Percona Toolkit and other stuff. I currently work at Block, which is now Square, the fintech company, renamed to Block. Block's the parent company that owns Square, Cash App, Tidal, and some other stuff. So I work there as a DBA. And I recently published Efficient MySQL Performance by O'Reilly. It just came out recently. And this talk is loosely based off that. But I say loosely because I really dislike when you come to certain conferences, especially open source ones, and presentations are really just a sales pitch for something. It's a real pet peeve of mine. So this is not a sales pitch. Excuse me if I reference the book, but honestly, you or perhaps the engineers that you lead and mentor can learn all of this stuff from the MySQL manual. I mean, heck, that thing is like over 1,000 pages. So technically, it's in the MySQL manual. Technically, it's scattered throughout blog posts and other books. You don't have to buy my book. You can learn it other places. So not a sales pitch. You can learn it online. In fact, I'll put a link to these slides where you can go to my website and access more information. So the important part about this, as I was kind of joking earlier as people came in, this talk is really intended for, first of all, not for DBAs, not for experts. It's really intended for engineers using MySQL, and that's true for my book as well. The book is, although the title looks like maybe it's an advanced read on MySQL Performance, the whole focus of the book is engineers using MySQL. So maybe you're new to MySQL, perhaps you're a college graduate, good programmer, knew all the general tech stuff, but you get out of college and now you have a MySQL database to work with. So I presume you're a professional, but you don't know MySQL. Or perhaps you do know MySQL, you've been using it for however long, but you want to level up. You want to kind of bring home all that knowledge and fine tune it. But it could also be, and I'm guessing that is now going to be most of the people in this room, perhaps this is live streaming, I was told, so okay, it is live streaming. So maybe people watching, is there actually video on me or just on the slides?
Just on the slides.
Okay, great. I don't like to be on camera anyway, so. It could also be for leaders and mentors, for those teaching other people MySQL. And again, that's kind of like my position and my colleagues here. We are MySQL experts, but then we interface with hundreds or thousands of software engineers who are not experts and don't want to be, and that's not what we hired them for. So perhaps we can take this and use it as the learning path for them. But really, it's intended for people who aren't DBAs or experts. So the focus in this talk is I am presenting a path for learning how to understand and achieve better MySQL performance. And very explicitly in this talk, I am presenting just the path and points along that path. I'm under no illusions where in 50 minutes I could dive into all these topics. It's not possible. Sometimes learning this stuff, takes a year or more. I mean, this is why I wrote a book for all the details and stuff. So I'm not diving into details here. I am presenting a path that, again, engineers who are new to MySQL can follow this path and learn things along the path to efficiently and effectively understand MySQL and MySQL performance and achieve it. So if I'm not diving into details, if I'm just presenting things along the path, then what's the value? Because in addition to not making sales pitches, I also try real hard to make sure that when I take people's time, that you leave here with something of actual value and not just the calming effects of my low, slow voice, lowering stress. So the value is, MySQL is a complex thing, right? Especially the people who've been with it for a long time. Performance in general is complex, databases are complex, and if you're new to all that, it's difficult to know even like how to start, where to start, What do you start learning first and then next? How do these things relate and tie together? And that's what I'm presenting here, is how to start and where to go step by step. That alone is valuable, but then we could push it further and say, well, what's the value in that? The value in that is it saves people time, and most people like to have their time saved to be, efficient in their efforts, and that's partly why it's called efficient MySQL performance. And then hopefully that leads to success with MySQL, and then hopefully that leads to success at your job, and then hopefully that leads to, success in your life. I mean, in happiness, it could. I mean, MySQL's been a good career for me. I'm happy, and it's all thanks to databases, right? So there could be a lot of value in this, learning this. So I'll mention this again, because actually I have to catch a flight right after this presentation, so sorry I won't be able to stay around and answer questions. But this slide is already on my website, hackmysql.com/path, already there. I'll put this slide up again at the end of the presentation. So first I want to address why this concept of a path. I already briefly hinted at it. A path through what? Again, some of the experts here in the audience know that MySQL is like this big, complex black box, and inside there are other black boxes. So from the outset, it looks something like this. And especially to an engineer new to MySQL, they know that performance is in there somewhere. They know it because they come to conferences, they read about it, they know performance is in there somewhere, but where and how to get there? That's the daunting part. That's why you need a path, an efficient path through this darkness, through the maze, whatever analogy you want to use, to performance. And in this depiction, that yellow star is performance. That is our North Star. That is what we're trying to reach through the darkness. I didn't say it was the simplest path, and I didn't say it was the most straightforward path. I said it's an efficient path. As you can see from the zigzaggy stuff, it gets you there, and it avoids information that's not relative or relevant. It avoids common mistakes and gotchas and pitfalls, also valuable to avoid those things if we can. It avoids misinformation because, as you know, not everything on the internet is correct. So, sometimes if you're trying to learn this stuff through blog posts, especially like in the course of doing research for my book, every now and then I'd come across things that were maybe not flat wrong, but not anything any expert would suggest. That's the internet. So, a good efficient path, avoid misinformation, and also avoid out-of-date information. Things change, right? MySQL has many versions, long history. So an efficient path gets you to that star, that performance, and it gets you there in an efficient manner. So what's on the path? This is a relatively abridged, kind of compressed version of the path for presentation. But these are the 8 main points along the path towards understanding and achieving better MySQL performance. And as you can imagine, when you start to get into each of these points, there is a lot more to learn. But for the sake of a 50-minute presentation, again, I'm presenting the path. And of course, in the book, that's what the book goes in depth on these things and more. So these 8 things are what I'm going to kind of go through quickly here in the presentation as I present the path to you all. One last thing before we get into the actual content. To make sure that the slides are not a distraction, there's 8 points along the path, let's call it. For each point, I start off with a slide that's titled with the point along the path, and then on the left there's some bullet points, just a few interesting tidbits, I will say, to kind of capture your interest and say a little bit more about this point. But again, since I can't really go in depth on 8 things in 50 minutes, what I do at the end of each of these slides is there's a numbered steps, kind of like action items. So again, my intention is at the end of this conference, you get the slides from my website, which again, I'll have the URL, or there'll probably be a recording or something. And then you can reference this later and follow these numbered things on the side to actually begin diving into the path and learning these things. So without further ado, let's get started on the first one along the path, which is query response time. So I like to say MySQL does nothing, because that usually captures people's attention. But let me explain that, because remember our intended audience here. Our intended audience is engineers new to MySQL. So engineers like that, let's say, sometimes think that MySQL itself is slow. They think that like MySQL is this machine, and the machine's gears, like the internal parts, are like turning slowly, or maybe it's like needs some oil or something, and that MySQL itself is slow. But as experts, we can say that is rarely the case. Maybe our perception is a little different because we tend to deal with the esoteric parts of MySQL, but we know that MySQL has been around for 20 years. It is highly optimized. MySQL itself is actually quite optimized, quite fast, quite efficient. And that's the truth. So for the moment, let's presume that that is the case. MySQL itself is fast and efficient. All those gears are, well-tuned and turning very quickly. The real question we have to ask is, and that I put to engineers is, well, what does MySQL do? What makes MySQL do work? It's the queries that we, or the application, ask it to do. That's why I say MySQL does nothing. Really, the full version of that statement is MySQL does nothing except for what you ask it to do. When it's just sitting there, most of the metrics are 0, right? It only does what we ask it to do. It only, and of course I'm simplifying things here, it really only executes queries. And moreover, it executes the queries on the data that you've stuffed into the poor database. So interestingly, we often talk about improving MySQL performance. And again, if you're Vadim, maybe you can actually improve MySQL's performance itself. But really what we want to do is improve the work that MySQL does. We want to improve what we put into it and ask it to do. So saying, oh, let's improve MySQL performance, I would say it's, especially for new engineers, maybe more accurate to say, let's improve the queries and the data that we put into this thing and ask it to work on. And so that is why this last bullet point exists. Performance is query response time. And in fact, that's the very first statement of the book. And that is how I kind of frame everything for new engineers. Performance is query response time. How fast can we get MySQL to execute a query and get back the results? Because that's really all we're asking it to do. Again, from user. As DBAs, we have other things going on like replication and whatnot. But from the intended audience point of view, that's what matters. Performance is query response time. And frankly, we know this from experience. When query response time is good, does anyone even look at the database? No. If your queries are fast, does anyone really care? No, probably not. But here's a more interesting thing to ask. Why is it the case that query response time is so special among the metrics? Why isn't it QPS, for example? Because that's kind of important too. Why is query response time so important and the North Star of MySQL performance? Well, I can demonstrate to you in a somewhat strange way why response time is so critical and pivotal and important and why it is performance. And here I'll do this demonstration. Response time is the only metric we experience. Just like that long, awkward pause of silence, we experience time. We experience response time. I know Brian loves it. But it's effective, right? You can't experience QPS. You can't experience a million rows read or a million rows affected. But your users experience that time. That's why it's so important. But yes. Yeah? Yeah. Good. Well, you have an intuitive sense. Yeah. We experience response time. That's why it's the North Star of performance. And that's why it's the first step along the path. They say don't do awkward silences, but, they also say break the rules, so what the heck. So yeah, action items for this one, again, after the conference, go choose a tool. There's lots of tools that work with query response time. Fortunately, there's many today. Then you have to enable and configure it, which since my book's not for DBAs, I don't explain it there, but I did a blog post on it, because as you can imagine, it's somewhat tricky. Then analyze slow queries, and then begin to teach this to other engineers, that the North Star here is response time, because that is the one we experience. So those are the action items. Second one, indexes and indexing. First of all, I'm going to say this one real quick. For all index usage, the leftmost prefix requirement holds. That is the most fundamental, most basic thing. Again, as I recognize some experts in this audience, you already know that, it's second nature, but for the intended audience, people new to this, they have to start there. They have to understand this deeply, and it has to become second nature. And I won't say more about it here, because this is definitely one of the things, like even the MySQL manual has whole long sections on what this means, examples, et cetera. You can find lots of books, but it has to start there. So make sure that they have a good understanding of what that is, how it works, et cetera. More importantly is the second major point there, and then the 5 below it, which is, I'll start off by saying, with respect to indexing and indexes, those exotic query optimizations are not the goal. They're attractive, things like, say, index condition pushdown or multi-range read. There's a whole list of them. You know, the manual has a long list of these optimizations, and they're alluring in a sense that you want to learn these things because those are the optimizations, right? I want that ICP or that MMR. But I would say don't dive into the deep end until you have learned to swim. And learning to swim means learning the 5 basic use cases for which MySQL uses an index. And again, I'm not going to go into the details here. Even the manual spells these things out. But it uses an index, obviously, for a where clause, of course, for group by, for order by under certain conditions, covering index under certain conditions, and of course, everyone's favorite, it hopefully is using an index for a join. It better be. There are some other more bizarre ones, like certain aggregate functions. There might be an index optimization. But these are the basic 5. And you need to start there, because otherwise you can't begin to understand those those query optimizations based on indexes. And I can tell you that this was my experience when I very first started with MySQL long ago. You're attracted to those query optimizations. And I was trying to learn all of them, but there's so many, and they're so very like context specific, right? They depend on specific things in the query and the schema and the indexes. And if you try to learn indexes and indexing that way, it just doesn't work because you haven't started at the foundation, and the foundation is those 5. So first, learn those 5. Learn how the leftmost prefix and those 5 work. And then, once that has become easy and comfortable, second nature, then you can look for opportunities to do those query optimizations. But don't force it, because here's the other thing that's weirdly not said very much. If you cover those 5 basic ones, like let's call it basic indexing, MySQL is always looking for opportunities to use those query optimizations. That's what its query optimizer is for, right? So in certain circumstances, you can kind of force or motivate a particular optimization, but oftentimes you don't, because MySQL is already trying to do that for you, and it knows, frankly, a lot better than most engineers. So get the 5 nailed down tightly. Look for optimizations, but a lot of the times you can just trust the query optimizer to pick out one of those optimizations when it is possible. So, last point. Indexes provide leverage against data, and here's another interesting thing to think about. And I won't do a weird demo of long, awkward silence and pause, especially after lunch. I'm sure people are falling asleep already. But why indexes? You know, obviously, we say, oh, well, because, what's that? Did someone say something? Or is it just the voice in my head? Okay, what's the difference? Why indexes? Oh, I see what it is. When I have my voice down, it changes the audio, so it sounds like someone's talking from the back of the room. Okay, I'll keep my head up. Obviously, we say we use indexes for fast lookup because indexes are in memory versus something on disk, blah, blah, blah. Indexes have a structure and an organization that lends it to programmatic access, et cetera, et cetera. But I would say there's a deeper kind of maybe philosophical reason why indexes provide leverage and why they're so important for performance. That is because they are the only thing that provides us leverage against rapidly increasing data sizes. Like data size can grow very rapidly. And indexes are the only thing that provides some sort of like physical leverage against that. You know, your data size can keep growing, growing, growing. And if you have good indexes, you can keep like reestablishing that balance with that huge amount of data with the right indexing and access patterns and other stuff. But without index, there's no hope. Without indexes, data will grow and databases just couldn't remain fast. So from a very high level, they are leverage against data, growing data sizes. So quickly, the action items here before we move on to the next one are explain slow queries. That goes back to the first slide. Query response time, look at your slow queries, et cetera. Use that as your North Star to guide your efforts. So start by explaining your slowest queries. Consider the leftmost prefix on those and how it works and the 5 use cases. Also run PT duplicate key checker because it's, you know, there's always a lot of duplicate indexes. And then browse section 821 is that section on select query optimizations. And you'll learn a lot more as you get into that stuff. So that leads us neatly into data storage and access. I like to say this too, data is dead weight. It's like rocks to MySQL. Data is really only valuable to you. To MySQL, data is work. It's dead weight that it has to work through. And fortunately, we have indexes to provide us leverage against those piles of rock, let's say. And there's an interesting proof that data is dead weight and useless to MySQL. I can optimize any single table, any query on that single table, doesn't matter what, I can get its response time to virtually 0. It's the greatest optimization of all. Truncate table. Please don't do that. You laugh, but it's true, right? Like if you remove the data, suddenly everything is so freaking fast, like it's near 0 response time. It's a weird little proof, but it is proof in a certain sense that data is dead weight. And so the main point here, at least insofar as presenting the path, is that engineers need to spend more time limiting and reducing storage and access, and I mean seriously. Less data, less QPS, less everything. And I know that's not common to say, although I spend quite a time in my book explaining it more and sort of arguing and proving for it. But one thing I've learned over my career is that second point, and I know my colleagues here will agree with me. Engineers celebrate less. They cope with more. Engineers love it when they have that, 10 terabyte database that's crushing things, and they somehow manage to migrate half of it off, and yay, now it's only 5 terabytes. Or when QPS is through the roof and they realize a lot of it's wasted or something, and then they reduce QPS, and now they have more capacity for other business work and stuff. Engineers celebrate less. They just cope with more. So really a focus on less, 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 and even less response time, meaning faster queries. But of course, a quick note, well, people say, well, that's kind of weird because isn't data growth and access, the growth of those things, like what we're here to deal with, isn't like that the kind of fundamental reason we address performance? And yes, true, but what I'm getting at here is don't let data growth and access be unbridled. Don't let it be unchecked. Keep some limits on it, actively reduce it and limit it. And then the last point here is that, I'm making very broad strokes. So this broad stroke is that access patterns and the working set size frame pretty much all of performance considerations. At least once a month, engineers ask me, oh, can MySQL performance be okay under such and such conditions? And it's always that, it depends, right? So for example, we can have a single MySQL instance with a huge amount of data. But if the access to it is very low and slow, then sure, it's going to work fine, right? Easy. The kind of flip side is true too, especially like in our industry. we have databases that are relatively small, but the access is very intense, very write intensive and read intensive. And even though it's not a lot of data, because of the access, it's difficult to scale performance. And so even though I'm making all these broad strokes, it's very important to impress upon new engineers that, well, saying it depends is probably so cliche at this point we should avoid it. It's better to say it's framed by your access patterns and working set size. And of course I can't go into that here. That'd be a whole separate topic to see how that plays out. But nonetheless, it is true. So the action items for this point along the path. Review and archive or delete any data carefully. I keep suggesting that. I know it's maybe not as fun as putting data in there, but again, data is dead weight to MySQL. Review your access patterns of the slowest queries. Again, I don't have time to talk about and go into the whole subject of access patterns, but that link goes to my website where I talk more about them. In case, again, you don't buy the book, which is fine, you still get information off that website, off my website. And then the last one, heck, consider a different data store. I love MySQL. It has been a good career for me, but it's just like this conference. This conference started off as just a MySQL conference many years ago, and now it's a conference for all open source databases. And sometimes that's what you need. Sometimes MySQL just isn't the right thing. Because again, access patterns are part of that framing, and not all access patterns are ideal for MySQL. So, fun one, sharding. I'm not going to say too much about this one, but it is an important point along the path because engineers tend to run into it, right? Usually for one of two reasons. Sharding is necessary if you really need to scale out write performance. And it is also necessary more for operational considerations, less so than data size. Again, engineers know, I can put 20 terabytes in MySQL. Yes, you can. But have you ever tried to run an alter table on 20 terabytes if it's under heavy access? What happens to your poor DBAs when they're most likely running some sort of replication topology and they have to clone that thing? So it's less about the data size and more about the operation. And that's not something engineers who use MySQL see, but it's something, well, they'll see it when their database goes sideways and the DBAs are telling them, hold on, I'm working on it because it's so large and slow. Around this juncture, this point in time, I generally recommend anywhere from 2 to 4 terabytes on a single instance, which is not a lot, I know that. But you have to take into those, well, we as DBAs have to take into operational considerations. And then we have to communicate that to engineers. But again, I will say this again, even this is framed by the previous access pattern, the mention of access patterns and working set size. They frame this consideration. I know lots of applications that get pretty big but don't ever have to shard. I don't know why they seem to hit a certain limit, but some applications never shard. Fine. But many, many do. So engineers using MySQL, prepare for it. The important point, though, is don't worry too much about it, though, because this is a solved problem. Lots of companies have sharded. Lots have written about it. Lots of material. It's a solved problem. You'll figure it out. Teams always do. More importantly, increasingly, there are alternatives like Vitess and PlanetScale. So if you're not aware of these, go research them. And the future is bringing us new SQL, which currently is TiDB, Cockroach, YugaDB. So there's new stuff on the horizon to look into. Action items on this one. First of all, start by measuring and monitoring data size so you can plan ahead. If you have this data size that keeps growing by a terabyte every 6 months, it's probably good to know that and probably good to have a plan. Read about Vitess, read about PlanetScale, read about TiDB, Cockroach, and plan way ahead. Because maybe in 20 years we won't be sharding. Maybe in 20 years things like TiDB will be the norm and we won't have to shard. So next point along the path, another fun one, server metrics. So first of all, and I'm actually dealing with this now with engineers, server metrics, like show global status, those are raw elements. You need chemistry, analogously, to bring them together to make something useful. Why? as we know, but engineers new to MySQL discover in a kind of disturbing way. There are hundreds of metrics, I think maybe even over 1,000 now, and they are scattered all over the place in MySQL. They have different naming schemas. They're fetched and queried in different ways. And of all this mess, only a few of them are actually generally useful, like stuff you'd actually want to put in a dashboard. So if you get in there and you're like, this doesn't make any sense to me, like there's not providing immediate value to me, you can tell engineers that's normal. That means you're doing it right. Because yeah, we have to filter out the noise and bring some meaning to it. So it is not easy or apparent. But more importantly, the thing to know about server metrics is that they are a reflection of the workload. And now I'm going to mix my term here. So you can think of MySQL as a prism there. And the workload is like shining a full spectrum white light into one side. And then as you know, out the other side of a prism, it kind of, the refraction breaks apart the different colors of light. And that's how you can think of what you're seeing when you're looking at server metrics on the right-hand side. It's weird in English to say that they are a refraction of the workload. Technically, it is refraction, but we'll just say they're a reflection of the workload. And why is that important? Because oftentimes we look at these server metrics and we want to solve a performance issue by looking at the spectrum that comes out the other side. When in reality, that really can't be done. Because again, all those metrics coming out, they are a representation of something much more kind of complex going into it. And you have to view it this way. So they won't necessarily pinpoint and solve a problem because they can't. What they do is they reveal where and possibly what is kind of going wrong in the server inside MySQL. And then you pair that with a knowledge of the server to indicate, again, generally, why that might be happening, why you're seeing what you're seeing. And then in the final step, you pair that with a query analysis to discover and fix the true root cause. Going back to queries and query metrics, again, going all the way back to the first step along the way. Why is that? Again, because the first step along the way, what does MySQL do? Well, it does nothing. It executes queries. It's part of the workload. So if we're seeing stuff on the right-hand side that looks out of whack, we have to follow it all the way back to what it's doing that's part of that workload. And it's, again, in normal cases, it's part of the workload. Again, as experts in DBAs, we know that every now and then there's something funky going on inside the server itself. Maybe someone, I don't know, misconfigured the transaction log or some weird thing like that. But I'm talking in a kind of nominal case where the engineer using MySQL can presume that we did our job correctly and MySQL itself is fine, but it's not running quickly. So they can look at this picture and then trace it back to their workload, their query specifically. Last item on here, insight is proportional to your metric resolution. And probably more and more engineers are intuitively or knowing this automatically. But MySQL is fast, right? Thousands of queries a second, 10,000, lots of things going on. If you try to then monitor and report that at like 30-second intervals, it's going to average and smooth over so much information that you're not going to get a clear picture out the other side. It's analogous to trying to read a book on the other side of the room. I could see it's a book, I can see pages. If my vision is really good, I could maybe see sentences, but I'm not going to be able to get any meaningful information because the resolution is too great. So I suggest minimum 5-second resolution, if at all possible. That's probably a little bit more of a DBA thing, but it comes up in this action item here for engineers. First, learn about the common and useful metrics. Then increase resolution, and by that I mean that if engineers using MySQL find that their metrics are only like every 60 seconds, which you might laugh, no one laughed, but you all know that, for example, Amazon spits out MySQL metrics every 60 seconds. At that resolution, I am reading a book across a room. I can't really see much. So I encourage engineers to advocate for better resolution and clean up your dashboards and charts, filter out that noise, because again, there is a lot of noise. I see a lot of bad dashboards. And also try PMM, because they're experts, they spend a lot of time on this. So, replication lag. Interestingly, I wrote a whole chapter on replication lag. And you think, well, why could that be? Because it is a common problem for engineers using MySQL. First of all, I stress the point that lag is data loss. And engineers using MySQL need to see it that way. It's inherent, though. Whenever you have replication going across a network, you all know that latency is inherent in the network. You can't escape it. That's fine. But you do have to realize that it's there and treat it as a serious thing when it becomes, heck, if you're really ambitious, treat it seriously if there's more than 1 or 2 seconds of replication lag. I'll come back to this in just a second. The second point is that it's caused by the application. This is why I spend a whole chapter on it. Again, we know that sometimes in rare cases, maybe the network is having a bad day, and the network itself is actually causing mass replication lag. Although DBAs can usually see that, because when we suddenly see 1,000 independent clusters lagging all at the same time, it's probably something common like the network. Again, in the nominal case, an engineer using MySQL, replication starts to lag, and then they come to the DBA, what are you doing to my database? Oh, well, of course, I climbed inside the database and I started just breaking stuff because I was bored. No, it is caused by the application. It really is. Again, other cases notwithstanding. And so that's why I spend so much time explaining how and why and just enough of the internals of replication so engineers understand what they're flushing through the figurative pipes of the system. The other thing I tell engineers is that it's difficult to precisely quantify and say when it'll recover, and I'm sure all the DBAs in here know that. Like, we know it'll recover, and we have some tools to give us some ideas, but it's always ballpark estimates. Engineers want to know, like, is it going to recover in 5 hours, 30 minutes, et cetera? We can say, well, maybe like a few hours or something. That's also normal too, so we just assuage their worries, and it's like, it's okay, it will recover. There's just no better state of the art right now. And down to the last point, the important point of all this is, because it's inherent, it's normal, it will eventually recover. The key thing is to just make sure that you monitor and page the team and respond to it. I don't know, where we work, we page the application that owns it if replication starts to lag. Because it's caused by the application, what can we do other than page the application owner? No, so we just page the application owner directly. And they log in and say, what are we doing to replication? And to do that all the time, 365, 7 days a week, 24 hours a day. So action items, again, to engineers using MySQL, absolutely make sure that you are monitoring and paging 24/7, 365 on replication lag, because it is like ongoing data loss kind of inherent in the system. And maybe some of you all are thinking about semi-synchronous replication, multi-threaded replication, et cetera, et cetera. Yes, those are all like DBA considerations, but again, I'm talking to engineers using MySQL. And the second thing is attempt sub-second measurements. Again, the state of the art with this is not the greatest. There are ways to measure replication lag sub-second. Not everyone does it, but we should strive for it. Second to last one is, oh yes, transactions, the fun one. Although I start off with, I call this step along the path transactions, but I actually start by talking about everyone's most favorite topic, Nodb locking, which is quite subtle, to put it gently. But the interesting thing is, if you didn't know, it is much more observable now in 8.0 because of performance schema data locks table. If you haven't used it yet, like, you got to go try it. It's so great. With that performance schema table, it will tell you all the data locks that Nodb has acquired, whether it's waiting for things. It's wonderful observation. But why locking in the path about transactions? That's because locking and transactions are closely related, at least in terms of the C and I and ACID, consistency and isolation. Again, I'm not going to go into it, but engineers should learn a little bit about the locking. I mean, heck, there's a lot of experts who only know the basics about Nodb locking, so tread lightly in this area, but learn some of the basics because, as we know, it affects query performance and locking and can have other effects on transactions. The locks of one query can affect another query, and so it's a fundamental part of the database. Yes, I get that it's kind of difficult. Believe me, I know I did a lot of research for it, talked with a lot of experts. It's crazy. At one point, I even had to talk with the guy at Oracle who is responsible for all the data locking code. I cannot pronounce his name, but I had to talk to him to reveal some of the deeper mysteries of the things I was seeing. So be careful, don't get lost in it, but do learn some of it because it is important. And also don't guess. Even experts, this is too subtle, even experts don't dare guess on Nodb data locking. Just use 8.0 in the performance schema data locks table and have it tell you. Because even after that, you're going to have a fun time figuring out maybe why it has locked certain records with certain lock types. It's a fun exploration, I think. Oh, and last thing along that is you have to be extremely precise. That's the other thing to tell engineers. You can't ballpark it. Like locking depends on every index, the schema, the transaction isolation level, which is really kind of like why this appears in the transaction section. Every little detail. Believe me, there's a lot of them. So if and when engineers get into this, details, 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 and don't guess. Second point there, I say that if a transaction isn't fleeting, it's defeating. And interestingly, actually, Jean-Francois just mentioned this in your talk. Transactions have to be small and fast. You have to get those transactions flowing through the system. And you'd be surprised, that's not always the case. Engineers don't always treat it that way. And then strangely, when a transaction is slow or having problems, it's like back to the very first slide, right? They're like, oh, MySQL is slow. MySQL's transactions are slow. No, actually, its transactions are super, super fast. But you are doing some sort of weird business logic in the middle of a transaction, and that transaction happens to be holding locks that aren't released until the end of the transaction, and then it's a snowball effect. So make sure those transactions are fleeting, quick, very light, small, and so that way they can also flush through replication quickly. Unfortunately, last point here, transaction monitoring and reporting is, I call it nascent, to be nice, to be polite. It's poor. It's difficult to see these things. I'll go actually bottom up just for excitement in this talk because I see everyone is falling asleep. That's not the case. There's still several of you with eyes wide open. Again, in the course of doing research for this book, I tried to find better state-of-the-art for monitoring and reporting transactions, which is tough because historically MySQL just didn't expose too many things, right? It's gotten better with the performance schema, and it is technically possible, but I'm not aware of any widely used tools that stitch it all together. So if you go to my website, hackmysql.com/trx, I reproduce the performance schema queries that are in the book. And that might be the best state of the art we have with respect to reporting transactions. Because there's other things to know in addition to just how long they take. For example, how many rows did a transaction access? That's an interesting one. It is in there, but again, the tooling just is not the greatest yet. Number two, review the code. This is, again, for the application engineers using MySQL. Have them review code that is using explicit transactions to make sure that they're not doing some sort of weird stall, or to make sure that they're, catching exceptions. Because another thing is abandoned transactions. Oftentimes engineers don't understand that if you abandon a transaction in a certain way where it can't be detected and rolled back and blah, 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 it just stays open. And MySQL is very patient, and it'll just keep that transaction open all day. And I don't talk about it here in the presentation, but in the book, and as experts know, that can cause a buildup of undo logging and all other sorts of effects. And then number one, use 8.0 to examine the data locks on slow queries. Again, it's always going back to that first thing, performance is query response time. So when you're learning these things as your source material, apply them to slow queries because those are the ones you need to fix. Oh, I've got 5 minutes and we're right about, there are the end. So this is the last one, the cloud, the fun one, and timed very well because I'm not going to say too much on this one. I'll go through these bullet points and then I'll expand on one of them. So it's important to know that network-backed storage is roughly the latency of a spinning disk. I was doing some benchmarking recently and I can get a steady 1 millisecond on Amazon's network, sometimes even sub-millisecond. But that's just the network, it's the nature of networks, right? They have latency. So if your hard drive's going through that network, you're going to have like a 1 millisecond commit latency, whereas of course you all probably know on locally attached storage, it's going to be more in the microseconds. So that has a significant impact, at least on write throughput and performance. The other interesting thing that haunts me, seems frequently, is, the cloud is like, oh, we're affordable. Yeah, buy a virtual instance with 1 or 2 or 4 vCPUs. But boy, that is like going back to early 2000s or maybe like, I don't know, late 90s perhaps with just 2 CPU cores. I mean, MySQL will work on a single CPU core, but then are you surprised when like CPU is pegged at 100% and like you have a production application hitting this poor thing? And I tell engineers, well, MySQL has a few threads running in the background. Although I began by saying MySQL does nothing, it has a number of background threads, and then it has its main thread, and then, like any machine, it has work to do too. In addition to executing your queries, which are in foreground threads, and if you only have 2 CPUs, well, that's a lot of scheduling going on those poor CPUs. So yeah, they're cheap, but don't be surprised if, it struggles a bit. That's the cloud. And I say that because I see a lot of people put MySQL on like 2 poor little vCPUs. Cloud providers are not DBAs. I'll come back to this one. And then the last one is probably obvious. Because things in the cloud are network-backed storage, because your CPU count might be super low, performance is even more critical. Again, access patterns, working set size, frame all consideration. I know many applications work great in the cloud, and others struggle in the cloud because of these cloud-specific things. So back to this, cloud providers are not DBAs. In hindsight, maybe this benefits me more than engineers using MySQL, so they understand and appreciate the work we do for them. But this is true, and I give a number of reasons in the book, but on here in this talk, I'll give you 2 real-world examples. So the first one is, on a number of occasions, I won't say which cloud provider, but they reported that the MySQL instance was all green, perfectly fine. But it was absolutely not the case. Nobody at our company could connect to the thing. I couldn't connect to the thing. None of our tooling could connect to it. From our perspective, it was not okay, but from the cloud perspective, they said it was totally fine. And that's the nature of it, and we understand their position. But here's the thing, that doesn't do the engineer any good. They trust the cloud provider. If the cloud provider says all green, they somewhat trust that, but that is not the case. Moreover, if they start to get into cost considerations, that does not count against their SLA. They will not refund you any money for that. The fine print is very specific. Their uptime is based on their measurements, not necessarily your measurements. So that happens. Real DBA, like for our on-premise stuff, of course we would never let that happen because we're all there together. But there's a side to the cloud provider that we can't see. So from their side, they say it's okay, fine, but that is not always the truth on the ground, so to speak. And the more interesting one, the one that's kind of near and dear to my heart, because it really just confuses me. So again, one of the cloud providers, a product feature is cross-region replication. That's their product feature. But here's the kicker. It will break, and they will not alert you or do anything. It's like, well, okay, if this is your product feature, and it's built into the systems and everything, and you're taking care of it and setting it up. In all other cases, like if I fail over or this or that and you fix it up, why do you do nothing if it breaks? I mean, that's ludicrous. Like, it's your product feature. And I can't go into specifics because I don't know if like my NDA allows me to tell these things. But there's part of it that is behind the scenes that customers would never know or be able to see or even tell that it is broken. I only know it because we have NDAs with the company, so I know how some of their back-end infrastructure works. So when I see this breakage on certain times, I know that it's their internal back-end thing that is broken. And that is crazy, and they don't do anything. I have to go fix it, even though it's their product feature. So again, cloud providers are not DBAs. Action items here, really just review everything, especially in the cloud. Like review query metrics, review those server metrics, review costs if you care about costs. Sometimes we don't. It's pretty fun when you don't have to worry about costs. It doesn't last long, but enjoy it while it does. Review what exists. In other words, like dead instances, things you didn't clean up. I'm notorious for this. I have MySQL instances all over the cloud that I should probably clean up because one of them is pretty damn expensive. Oh, and if you really want to get a sense for what goes into operating a database, again, I'm kind of talking to engineers using MySQL. I have this thing that I call the Database Operations Manual that I have on my website there, and it is a long list of things that DBAs take care of. And you can very quickly see that the cloud is falling short on a lot of that. And then engineers begin to realize, oh, okay, yeah, they're running MySQL for me, but I'm going to either have to watch it myself or rely on my DBAs. So that is it. There is always a lot more to learn. There's even more to learn in the path, and especially when you get into each of these particular points, as some of the experts in here will know. A lot goes into each of these points. That's why I kind of tried to distill it all in the book. Or after the presentation, you can get these slides off my website. And if you're an engineer new to MySQL, or maybe not new, but you've been using MySQL and you really want a more kind of rigorous approach that will efficiently lead you to an understanding and achievement of success, 1 to 8. Start with query response time, everything that entails. Get into indexes and indexing and everything that entails. Then data storage and access, sharding, server metrics, replication lag, you learn about replication 1, transactions and data locking, and then the cloud considerations, and that will lead you to better performance. So thank you and good day. And that's where we can put the slides.